Right, this is June 09, paper 1. The question says, what is friction? And friction is a force, so that's your first mark. And what does that force do? And our easiest definition is it is a force which opposes motion. Friction is a force which opposes motion. Right, the car shows a car on a level road. The arrows show the two horizontal forces acting on the car. The forces are equal. What is the resultant of these two forces? So if they're balanced forces, then the resultant is 0. And we'll put newtons in as well, but you don't really need it. Answer is 0. State two possible states of motion of this car. So this is really asking you, do you understand Newton's first law, which is the law about balanced forces? And so if you remember Newton's first law, a body is either at rest, so the car is either at rest, it's not moving, or if moving, moves at a constant speed or a constant velocity in a straight line. So a constant way, I'm going to write down a constant speed here. If the force B does not change, but force A is increased to 1200 newtons, this produces an acceleration of 0.5 meters per second squared. So I'm going to write this on. A is now 1200 newtons. And it says calculate the size of force B. And we're looking for the size of force B. So we have to use F equals ma here again. F is a resultant force. This one is bigger than this one. So we're going to take that away from that to get a resultant force. So it's 1200 minus the force of B. And that's equal to the mass of 750 times 0.5. So this question then, F equals ma. F is 1200 minus FB, and that's equal to 750 times a half. So 750 times a half is 375. So therefore, 1200 minus 375 is equal to FB, and FB comes out to be 825 newtons. So there's 1 mark for your answer, 1 mark for this part of the sum here, and 1 mark for your equation. Force A remains constant at 1200 newtons, so force A was this forward force. But as the velocity of the car increases, the acceleration does not remain the same, but actually begins to decrease. What does this tell you about force B? And that means if this is actually getting smaller, then FB must be increasing. So FB, or the force B, must be increasing. The driver of the car takes it on a journey. The distance time graph for this journey is shown below. Calculate the average speed of the car for the whole journey. So you have a total distance here of 1200 and a total time of 160, and therefore average speed equals total distance over total time, and that's equal to 1200 over 160. That comes out to be 7.5, and you need a unit, 7.5 meters per second. So there's a mark, a mark, a mark, and a mark. Draw on the graph above what the distance time graph would look like if the distance had driven the same journey in the same time at a constant speed. So constant speed would mean there would be a constant gradient in that graph, and therefore if they're going to travel the same journey in the same time, that means that they have to end up at the same place, which is up here, and start at the same place. And so all you need is a straight line from the beginning to the end, like that. So that's a constant speed, is a nice straight line. And so you get a mark for a straight line starting at 0, and ending at 160, 1200. And that's how you get your marks there. On another journey, when the car is approaching a road junction, the traffic lights change to amber and the car brakes. The graph below shows the part of the velocity time graph as it brakes. The driver sees the light change to amber at a time of 1 second. So there, change to amber at 1 second. What distance does a car travel during this time of 1 second? And so all you have to do is get the area under the graph, because the velocity time graph. So area under graph, and that's just 8 times 1. So the distance travelled is 8 metres. The car stops 3 seconds after the brakes are applied. So there's where the brakes are applied there. Continue the velocity time graph until the car has stopped. You may assume that the deceleration of the car is constant. So 3 seconds after 2 seconds takes you up to 5 here. And therefore you're just drawing a straight line. You're told the deceleration is constant. That means that it's got a straight line on the graph and it's downward because it's deceleration. A nice straight line down like that. So you get a mark for a straight line and it ending at 50. That's your 2 marks. Last part of the question, calculate the deceleration of the car. So you can use the gradient of the graph or v minus u over t. We'll just use the gradient. And the gradient is going to be equal to 0 minus 8 over a time period of 3 seconds. And that gives you a negative value, minus 2.67. Or for just deceleration, we'll just write 2.67. Again, they'll not penalise you for writing a minus down here. It is a minus acceleration or it's just a deceleration. So there's 1 mark there and 1 mark for your calculation. Calculate the distance travelled by the car from the time the driver sees the traffic lights change to amber until it comes to rest. You're advised to show clearly how you get your answer. So the driver sees the traffic lights change to amber here. And so what you really have here is this rectangle, which is here, and a triangle, which is this part here. And so the rectangle has got a width of just 1 there. So area equals distance under graph. So that's equal to 1 multiplied by 8, which is your rectangle, plus a half times 8 times 3. And that gives you a total of 8 plus 12, which is equal to 20. And so you get a mark here, and a mark here.